Okay, let's get started. All right, so where are we in this layer cake? So the data access layer pieces are almost in place, so we can go back to the logic layer. So as I was describing yesterday on the stream that will forever be lost to the sands of time, the database layer is of course in Postgres. The web server layer is of course whatever web server technology I'm using. And where I control the code is in these three layers, with this layer interfacing with the database, this layer interfacing with the web server layer, and my custom logic in the middle, in kind of the middle layer. And so I started by working on the bottom layer, and then as I moved up into the middle layer, I realized my image, which represents an image like a JPEG or a TIFF or whatever, couldn't be represented without bringing in an additional data layer service, which is my metadata service, which goes through and queries the metadata I'm running in my server. And the metadata is the, basically when it was captured, where it was captured, if it's a video, the runtime, and related tags about the image. And that has a one-to-many relationship with the locator. So the same metadata. In this case, you see if the metadata IDs are the same, but this points to two paths on the file system, so the same image can be in two places at once. And that's because I have a lot of images that are in fact duplicates. At least they indicate that they're duplicates by their hash. So because of that, I have to account for the fact that we could have an image that appears in two locations on the file system, or maybe it's on one location on the file system, and then it's also in like a blob or bucket somewhere on like AWS, or maybe it's an API for files or for images. But anyway, it appears more than once. So yesterday we implemented these find functions, and they are largely and formulaically the same. So if we look, this one's a little bit different because we have to build a query because we don't know how many tags there are. This one is straight up find by the date range, and this one is find by location. And if we go to the queries, find by location and find by date range are very similar. The one thing that we do have to build is when we're searching for tags, because we don't know how many tags might be in the query, we need to look at adding this so that we build up a query that looks like just so that's what we're trying to build up, right? So we do that in this function down here, build query. Now, here's the thing. What's the difference between all these queries? It is just their where clause. And in fact, I kind of want all my queries to be ordered by this. I think that makes sense. But maybe that should be its own thing. But we have this build tags query. which just builds this one but doesn't build this one, but it could, right? So let's start by creating a query builder. And we want this to be a fluid interface, so we want this to be a fluent interface, so every function will return a query builder. So and we can add, for example, we can let's look at adding additional tags. Let's say add tags, and we pass n tags, and that's it. So the number of tags, and we return back a query builder. We don't need the parentheses here, right? Now, what should the query builder contain? So maybe what we need to do, no. Yeah, so what should it contain? It should contain a string builder, right? And so we should probably have func new query builder. That should return query builder, and return okay, and that's fine. Okay, add tags. QB dot between dates. And the dates will be parameters. And QB query builder at location returns a query builder. Okay. Okay, and we should have something like finalize. Oops, I'm getting ahead of myself. And this returns a string, which is our query. All right. So that's what I think we want. We want to be able to call this fluently, so we can say new query builder, add tags, between dates, at location, finalize, and get back our query. Okay, so let's go ahead and actually park this in a separate file. And it's related test. All right, so let's do this. Func. Let's do test query builder, add tags. We do one at a time, right? So query builder, okay. Tags, and we're going to add 3 tags. All right, and so we know what the query should kind of look like. It should look like, let's go back to metadata service. It should look like where so this should be 1, 2, and 3, and it should end in this. And you know what? Okay, let's go with that. Okay. So if target not equals query, all right. Now here's one problem. We might have small differences in white space. We certainly don't want that to be any reason why the query builder fails, right? So we're going to need to normalize the white space. And to do that, I'm going to, this isn't really just a general query builder, right? It's really a metadata query builder. So let's go ahead and rename this metadata, as one of my professors used to say. Yes. Okay. And factory name metadata. New rename. New metadata query builder. Okay, fine. Okay, I'm happy now. Okay, so we've got small differences in test metadata. All right, so let's take care of these small differences in space. Don't want that. Must compile. replace all string. Source string, query. And I want that to replace with a space. And this should be, in my mind, oops. There we go. So any one or more white space gets replaced with a space. Well, if it's RN, if it's RN on Windows, it'll be both RN. So yeah, that should be good. And of course, that's not needed. Let's just go ahead and compile it up here. And do white space, replace all string. Okay, close. And this will be target. All right, so let's run this. And this should fail, right? Whoa, that's not cool. Stack Overflow. Maybe I should go on to, well, no. So finalize. Finalize. Let's see. I don't really have a new builder. Just run it again and see if we get a Stack Overflow again. The Stack Overflow is a little weird. Oh. Oh. And that's why we run tests. All right, and let's change this to string. I like that better. All right. So we have at least one private method, which is keep getting ahead of myself. Wrong language. Okay. All right, let's go back to here. So that's what add front matter does. So note that right string returns a possible error, but it's generally nil. So we don't care about that. We don't care about that. Okay. What can we know from, let's see. Len. Let's see what len does. Returns number of accumulated. Okay, that's what we want. So if zero, so we got a fresh one. Okay, so let's add the front matter. Then for actually, let's do this 1i and tags plus plus. Let's go ahead and QB right string, and what do we want to write? We want to write this. Wrong language. And if I is less than n tags, there we go. So let's see, what's the test? Order by metadata ID ascending. So we want to add this at the end, right? And we need to do that in finalize. Right string. Nope, can't return that. So let's go ahead and clear it out, because I know that will be a temptation to reuse the exact same one, and I want people to be able to do that safely. B.B equals strings dot builder return result. There we go. All right. Now let's run a test. It should pass. Let's see why it didn't pass. All right, let's take a look. Actually, I think I may know why. Trailing space. So let's do this. Dot strings dot trim. And the cut set is space. Strings dot trim. Strings trim. And again, the cut set is space. Now let's run it. Okay, let's see why this didn't work. Okay, let's split it up. Get rid of that expected because that's just going to visual clutter. And aha. So we did not actually fill in this. That's why I went from 1 to whatever. Okay, now if we run it, pass. Okay, good. Okay. Let's go ahead and test between dates. Query builder between dates. What do we want our target to look like? So we want from metadata where date captured between okay. All right, so QB equals, whoops, new metadata query builder, query between dates. We're going to do the exact same thing here. Clean out the white space. And there we go. So if we run this, it will fail. Or should fail, right? So we expected that, but got nothing. Oh, the order by. All right, so let's go fill in this function. QB dot len So first we have the front matter. If it's a new query, right string, we know what we want. Keep hitting tab. Now if we run it, it should pass. Okay. And let's add location in there. That's the same. Where location equals $1. That's all we want. We've got our cleaning, and instead of calling between dates, we'll call this at location. And if we run this, it will fail, right? Yes, of course it'll fail because we haven't implemented it. So let's go implement it. And in fact, this is basically cut and paste, right? Where location is equal to $1. And now if we run our test, it'll pass. Okay, now let's test this and make sure it's a fluent API. So func test. And we'll test, well, what if we do between dates and then add tags and then add location? So let's do, so this stays the same, and this becomes between dates. Add tags, 3, at location. Okay, that's our query. What our target looks like. Our target would look like between dates, where date captured between and again, white space is going to count, so I'm just doing this formatting for my legibility. And it's a syntax for tags. Oh, that's it. Okay. So we're doing 3 tags. Except we've already got a $1 and $2, so this needs to be a 3, 4, and 5, right? And location. And location is equal to $6. So, okay. If we run it, it'll work, right? Because we've implemented all the, oops, I ran the wrong one. We implemented all the methods. But no, it doesn't work, because if we look at the output, we don't reset the counter, so the counter values are wrong. And we've got some missing ands. All right. So let's go back to the builder. So, first let's fix the problem with the resetting. So we will carry an I, and that'll be an int. And we'll set I to 1. Actually, let's call this IDX. Right, equals q.b.idx qb.idx dx. There we go. Equals qb.x plus n tags I plus plus. Okay, that should fix that. And this should be format sprintf. And this should be %d, %d, and we do qb.idx plus plus qb.idx plus plus. And let's see, oh, missing a paren. And finally down here, and we want to do a sprintf and qb.idx. Okay, so now if we run the test, okay, let's go take a look at our output. But God. Okay, 3, 4, 5, 6. Oh, we did not update. We did not update. No, this needs to be QB plus n tags, right? Yep. If we run it again, let's go make sure our numbering is correct. Where date capture between 1 and 2, 4, 5. Okay, had that math wrong. So 1, 2, 3, 4, 5, 6. Okay, great. So now that we've got that correct, let's talk about if we've got something. So if we've got a query started, then this clause will be joined by an AND. QB.B. And this is the same for all of them. So if we've started a query, we have to join it by an and add a new clause, right? So now if we run it, it should pass. Nope. Let's go take a look at the results. So let's take a look at the results. So let's start by select from, sorry I'm a little rushed this morning, data capture between 1 and 2, right? And 3 equals any tags, and 4 equals any tags, and 5 equals any tags, right? And location 6, order by, okay, that's what we want. Okay. Where date captured between $1 and $2, and $3 equals any tags, and missing some ands there. So was my original test correct for? Yeah. Well, let's take a look at the original test. Yes, it was. So let's take a look at the implementation. Add tags. If I less than I plus n tags minus 1. Right? It's not I less than n tags because I could be starting after n tags. So it's I, so if I is 4 and we have 3 tags, this is if I is less than 4 plus 3, which is 7, which would be after my last tag because the tags would be 4, 5, and 6, minus 1, 6. So as long as we have one more tag to do, go ahead and write an AND. So now if we run it, we should pass. Nope. Let's go take a look and see what went wrong. Okay. Select from where and so that's what we're looking for. And what do we get? Oh, we got 2 ands. So the logic here is incorrect. So where I, so it starts at 4, is less than 7 end tags. So 4, no, that's because that's qb.idx because it's not I, right? And so we pass. Okay. I think that's enough for today. Let's go ahead and get rid of this comment. Is there any quick and dirty refactoring I'd like to do here? Yeah, maybe change this method a little bit. Get rid of the if statement in all the clauses. So have something if qb.b.len is equal to 0. Go ahead and write the front matter, else len. Sorry. Otherwise we do this, right? So this is saying if the string is empty, go ahead and write it in. Otherwise, write an and. So I think I can just go ahead and fix these. Alright, I should be able to run all the tests in this package, and they should all pass. Alright, great, everything's passing. Anything else I want to do quick and dirty here? Nope, that is actually unique logic to each one of them, so I think that is pretty spot on good. Alright, I'm just going to go ahead and quickly add some documentation to this. Fluent manner. These are just quick comments. We don't need to comment that. Adds a date range clause to the query. There. All right. I don't love this implementation of string. So here's what I don't like about it. So string, if you call string on a value, it should return the same value every time. And this one modifies its object. So if you recall it 2-3 times in a row, you get different results. And I don't like that. So what we really have is, so let's get rid of this. Let's not reset that. Let's change that to be sprintf qb.b.string. Actually, %. Let's not modify it. Okay. Let's do a quick test. It still works. There, now if I call string twice in a row, we can write a quick test for this. Call it string string. If I run that, passes. Okay, yeah, so I can call string multiple times and I will continue to get the correct value. Okay, I like that better. All right, a quick check on everything again. And everything's good. Okay, that is, okay, now I will actually really call it a day. Okay.